Hello students. So today we will discuss one reaction of aldehydes with Tollen'S reagent. See, reaction of aldehydes with Tollen'S reagent. This reaction is very useful for making distinction between the aldehydes and ketones. See, firstly we will discuss what is the Tollen'S reagent. Tollen'S reagent is the ammonical solution of silver nitrate. It is the ammonical solution of silver nitrate. See how it is prepared. We used to take the AgNO3 solution, aqueous solution, and in this solution we used to add sodium hydroxide. By adding sodium hydroxide in silver nitrate, here we'll get a gray or black precipitate is obtained, and in this gray or black precipitate we will add a NH4OH, or you can say that aqueous ammonia is added in the precipitate. So when you will add a aqueous ammonia or NH4OH in the precipitate will get dissolved and we will get a transparent solution. So this transparent solution obtained after adding the NH4OH, this is Tollen'S reagent. See, here the precipitate get dissolves because due to one complex is formed here. The Tollen'S reagent is a complex compound. So one complex is formed, and due to the formation of that complex, this gray precipitate, which is of silver oxide, is obtained. So this gray precipitate or black precipitate will get dissolved on adding NH4OH due to the formation of a complex. Now, how the what chemical reactions occurs during this reaction or during this process? See what happens here. Silver nitrate solution was taken, and this silver nitrate solution reacts with an alkali or NH4OH, and as a result here we will get a silver oxide, and this will produce a gray precipitate. See, write a balanced reaction. See, the NH4 plus ion of the ammonium hydroxide will combine to the NO3 minus ion produced by the AgNO3 and forming NH4NO3. Now one water molecule also sets free here. Now this silver oxide, being a transition element, will form a complex. When ammonium hydroxide means aqueous ammonia is added, so this aqueous ammonia or ammonium hydroxide will react with the silver oxide and will form a complex. This type of complex is formed here. So, in order to write the balance equation here, two water molecules sets free along with this. So, this one is the complex, and or we can say this one is the active species of the Tollen'S reagent. Say here, on adding the alkali in AgNO3, we get the precipitate which gets dissolved on addition of the NH4OH. So, by the addition of this NH4OH, this complex is formed, and as a result, the precipitate gets dissolved. I think here it should be 3H2O. Then it will be balanced. Okay. Now, this was the information regarding the Tollen'S reagent, that what is the Tollen'S reagent and how it is prepared. Now, we'll discuss and we'll come to our point that we were discussing the topic reaction of aldehydes with Tollen'S reagent. See, this Tollen'S reagent, these are, or we can say is, a very weak or mild oxidizing agent it is. We knows better. See, here it is a carbonyl carbon, and if at carbonyl carbon there is at least one hydrogen is here, then this group is called aldehyde. If at the carbonyl carbon there is no hydrogen, both sides I am adding an alkyl group, so this one will be called ketone. See, these aldehydes they can be easily oxidized. Even we can oxidize the aldehydes by using very, very mild oxidizing agent. So here, as Tollen'S reagent is also a mild oxidizing agent, so this Tollen'S reagent will oxidize the aldehydes, whether it is aliphatic or this one is the aliphatic, or it is aromatic. See, this one is the benzaldehyde. So, aliphatic as well as aromatic, both the aldehydes will be oxidized by the Tollen'S reagent. So, we may write a statement that aldehydes, whether it is aliphatic or it is aromatic, both. They reduces the Tollen's reagent. See, when aldehyde is taken, now if we are going to add, we are adding here a Tollen's reagent. This one is the Tollen's reagent. Here, the IUPAC name of the Tollen's reagent is, it is here the active species or the complex which is formed by the addition of the NH4OH. So this complex is formed and the name of this complex will be diamine silver first and hydroxide. This one is the Tollen's reagent. So what happens here? This Tollen's reagent, this one is a mild oxidizing agent, and the aldehydes, whether it is aliphatic or it is aromatic, they are having the hydrogen over the carbonyl carbon. There is a hydrogen directly linked over the carbonyl carbon, and due to this reason aldehydes can be oxidized readily. Here remember, aldehydes can be oxidized easily, and this is due to presence of hydrogen over carbonyl carbon. See, on the other hand, if you will see the ketone, or suppose it is a ketone, see, in ketone there is no hydrogen over the carbonyl carbon, and that's why the ketones will not be oxidized by the even mild or ordinary oxidizing agents. The ketones gets oxidized only under drastic conditions because there is no hydrogen over the carbonyl carbon. Now see what happens here. When Tollen's reagent is added here in aldehydes, whether it is aldehyde or whether it is aliphatic or aromatic, in order to write the balance equation, just take the 2 moles of the Tollen's reagent here. Now what happens? Here, as it is a mild oxidizing agent, so due to presence of the hydrogen over the carbonyl carbon, the aldehyde will readily oxidized. So this aldehyde will oxidized, and as you know, during oxidation we used to add a oxygen in between the stressed carbon and hydrogen. See, this carbonyl carbon is stressed carbon because is bonded with the electronegative oxygen. So we will add one oxygen here in between the stressed carbon and hydrogen. This will get oxidized. On the other hand, if the one species is getting oxidized, so the other one will be reduced. So this one, Tollen's reagent, will be reduced. Here the oxidation state of this Ag, see here it is +1. Now this Ag will be reduced, and this Ag will deposit over the inner wall of the test tube, and it will shine like a mirror, and This one is called silver mirror. See, now the Ag will be reduced and will get deposit over the inner wall of the test tube. See, ammonia acts as a ligand till there is a positive charge over the silver. As the Ag gets reduced, these ammonia will set free. See here, there are 2 moles of this Tollen'S reagents are taken. So here 4 ammonia will set free. Now see here, now acid, after the reaction we are getting here acid. So acid and ammonia is behaves like a Lewis base due to the presence of lone pair over the nitrogen. So acid and base can't exist together. So out of the 4 ammonia molecules we obtains, 1 ammonia molecule will react with this acid and forms the ammonium salt of the carboxylic acid, and the OH will set free in the form of the water. Is it clear? So this is the reaction. Here it is 2 water because there are 2 OH. Is it clear? Same way, here this is the Tollen'S reagent, will oxidize the aromatic aldehyde, and here we will add simply 1 oxygen between the stressed carbon and hydrogen, and thereafter the Tollen'S reagent will be reduced. Here Ag oxidation state is here +1. Now this +1 oxidation state will be reduced and this will come in the form of silver and will deposit over the inner wall of the test tube and will form a mirror and will shine like a mirror. So this one is called silver mirror. Now these ammonia molecules will set free and the OH comes out in the form of water. See, during the reaction we are getting what? Acid and as well as ammonia is there. Ammonia is a Lewis base. So acid base can't exist. So one of the ammonia molecule obtained during the reaction will form the ammonium salt with this acid, and here you will get the ammonium salt of benzoic acid, means ammonium benzoate, as in this case here we are getting here ammonium salt of carboxylic acid or ammonium carboxylate along with the silver mirror. See, silver mirror means this silver from Tollen'S reagent gets reduced and sticks over the inner wall of the test tube and it shines like a mirror. That's why this one is called silver mirror. See, only and only aldehydes reduces the Tollen'S reagents. Ketones does not, and therefore here the reaction is used for making distinction between aldehydes and ketones. So suppose the question is how to write a chemical test for making distinction between acetaldehyde and acetone. So we may make the use of the Tollen'S reagent. Tollen'S reagent will give a positive silver mirror test with the acetaldehyde, while acetone does not give this test. Is it clear?